started on today's notes over flowchart and paragraph proofs. We have been using the two-column proof, which I happen to love. That's my favorite one. But now I'm going to introduce a new style of proof. A flowchart proof is a style of proof that uses boxes and arrows to display the proof. The justifications, those are all of your reasons that we used in the right column of our two-column proof. Those are the definitions, postulates, theorems. Those are written next to the boxes. So let's work through this first example. We're given angle 2 and angle 4 are vertical angles. We want to prove that the measure of angle 2 is equal to the measure of angle 4. So let's write that. Let me see if I can write this down. Okay, I'm going to use blue here. So we're talking about these two angles right there. We want to prove that not that the angles are congruent. Our last statement has to be that those angle measures are equal. So we're going to start with what we're given. Let's fill out this two-column proof here on the left. Angle 2 and angle 4 are vertical angles. That's what we're given. So we know that angle 2 is congruent to angle 4. How do we know that though? We know that by the vertical angles theorem. So recall your geometric proofs reason bank. Vertical angles theorem is right here. If the two angles are vertical, then they are congruent. Okay, and we've proven that in a previous lesson. So the measure, let's go to our third step. The measure of angle 2 we know is equal to the measure of angle 4 by the definition of congruent angles, and that's right up there. So if two angles are congruent, then their measures are equal. So now we're going to take this two-column proof and we're going to put it in this other style of flowchart proof. And the first thing you can see right there written in the box is that angle 2 and angle 4 are vertical angles. So there's your statement. It's written inside your box. And your reason or justification is going to go next to it, underneath it. That's what we were given. And then it's a flow chart. So we have arrows that go to, and it just shows your chain of thinking, right? So like this is step 1, this would be step 2, this would be step 3 from our two-column proof. So the fact that they're vertical angles, well, that leads to that angle 2 is congruent to angle 4, and we know that by the vertical angles theorem. So that's what we would write there. And because they're congruent, we can then show that their measures are equal by the definition of congruent angles. So let's move on to our next example. And we're actually going to do a flowchart proof of this example. And then we're going to take that flowchart proof and we're going to do a paragraph proof. My least favorite, but it's very common, especially in the higher level math classes. A paragraph proof is a style of proof that presents steps of the proof and matching reasons as sentences in paragraph form. So let's start this example. Number 2, we are given that angle 1 is congruent to angle 3. That's what we're given. We're asked to prove that the measure of angle 2 is equal to the measure of angle 4. So again, we can't finish with the fact that they're congruent angles. We have to finish with the fact that their angle measures are equal. So let's look at this flowchart proof on the left over here. Right here, I have your first statement. Angle 1 is congruent to angle 3. What's our reason? Our reason is that's what we're given. And then I have up here, notice we're kind of starting up here where we don't have any arrow going to it. It's just our first thought is that angle 1 and angle 2 are supplementary, and angle 3 and angle 4 are supplementary. Well, we know that by the linear pair theorem. Take your geometric proofs reason bank. The linear pair theorem says that if angle 1 and angle 2 form a linear pair, then angle 1 and angle 2 are supplementary. So I can visually see that angle 1 and angle 2 form a linear pair, and 3 and angle 4 form a linear pair, which we can deduce that they are supplementary angles by the linear pair theorem. Okay, so let's move on to our next reason, okay? And it seems like we're jumping, but you can do this, okay? We are given that angle 1 is congruent to angle 3. So here we have angle 1, angle 2 are supplementary, angle 3 and 4 are supplementary. Well, if 1 and 3 are congruent, right there, so angle 1 and angle 2 are supplementary, which means angle 1 and angle 4 would be supplementary, right? And if two angles are supplementary to the same angle, this would be that same angle, then these angles are congruent. And I know that by the congruent supplements theorem right here, which says if two angles are supplementary to the same angle, then those angles are congruent. So angle 2 and angle 4 are supplementary to the same angle because angle 1 is congruent to angle 3. Okay, so that's kind of tricky. Let me erase a bunch of that because I've written a whole bunch down. Okay, so let's move on. So now we have the congruent supplements theorem. Angle 2 is congruent to angle 4, but remember, our final statement should be what we're asked to prove, which is that those angle measures are equal. So we know those angle measures are equal. The measure of angle 2 is equal to the measure of angle 4 by the definition of congruent angles. Okay, so now let's take this flowchart proof and write it as a paragraph. And I've already written a little bit down. So it is blank that angle 1 is congruent to angle 3. Well, it's given that angle 1 is congruent to angle 3. Then the linear pair theorem tells us that angle 1 and angle 2 are supplementary angles, and angle 3 and angle 4 are also supplementary angles. And I'm going to give you a little trick here. Here, let me write this down. Whoops. And then if you write by the, and then write your reason, then you can comma, then write your statement. Okay, so by the congruent supplements theorem, angle 2 is congruent to angle 4. And by the, definition of congruent angles, the measure of angle 2 is equal to the measure of angle 4. So by the, and then write your reason, okay, comma, and then write your statement. A lot of students really love this in a paragraph proof, and I don't hate it because it's your proof written as sentences in paragraph form, so that works. Let's move on. Number 3. This says to complete the flowchart proof for example 3, then write your argument as a paragraph proof. We're given that F is the midpoint of segment EG, and we're asked to prove that 2 times the length of EF equals the length of segment EG. So let's start. F is the midpoint of segment EG, right? That's right here. What's our reason for that? That's what we're given. Okay, well, that will lead to what? What will that lead to? What do we know? Well, we know that segment EF is congruent to segment FG, and that is by the definition of midpoint. If 2 segments are congruent, what do we know about their lengths? We know that if segment EF is congruent to segment FG, then the length of EF is equal to the length of FG, and that would be the definition of congruent segments. So there's your whole chain of thought, right? This, what we started out right here that I starred, okay, arrow down, that leads to that, arrow down, that leads to that. Now over here, nothing leads to this. I'm just starting with this, right? Which is that the length of EF plus the length of FG equals the length of the whole thing. And what is that? That's the segment addition postulate. So I'm just starting with that postulate, and we're going to take this postulate right here and this right here, the fact that the length of EF is equal to the length of FG, and we're going to come up with a new a statement and a new reason. So I have that EF plus FG equals EG. And down here I have that EF plus EF equals EG. What did I do? I can replace FG with EF because I've already shown that they're equal. So that's what I'll do. EF plus EF, I've just replaced it, equals EG. We use the substitution property of equality. Well, EF plus EF, that's the same as 2 times EF equals EG, and that's by the distributive property. So now I'm going to show you an example of what this might look like in paragraph form. I'm just going to give you a hint. If you want to say, we know that F is the midpoint of segment EG, or it is given that by the definition of midpoint, comma, segment EF is congruent to segment of G. And by the definition of congruent segments, the length of EF equals the length of FG. By the segment addition postulate, boom. By the substitution property of equality, boom. Okay. But I'm going to show you an example written a little bit differently. And you can pause the video to write this down. But this is just how you can phrase your paragraph. You need to make sure, though, when you're writing your paragraph, you have your statements and your reasons. They're written. So F is the midpoint of segment EG. So segment EF is congruent to segment FG by the definition of midpoint. The segments are congruent, so their lengths are equal, which means the length of EF is equal to the length of FG by the definition of congruent segments. According to the segment addition postulate, EF plus FG equals EG. Because EF equals FG, we can use the substitution property of equality to create the equation EF plus EF equals EG. Thus, using the distributive property, 2 times EF equals EG. So you can kind of fancy it up if you want. You just need to make sure you have every reason and every statement written in your paragraph proof. So I encourage you to pause the video and write this paragraph proof down in your notes. Let's move on to the last example for today. I'm going to introduce a new theorem today because there are so many theorems and postulates and everything to talk about when you get into geometry, or as you're in geometry working through proofs. I'm going to be slowly introducing you to theorems. The common segments theorem, which it shows that collinear points on the same line, are arranged as shown in the picture representation. So when you're given collinear points, shown this way, A, B, C, D, if segment AB is congruent to segment CD, then segment AC is congruent to segment BD. Okay, so we're going to complete this flowchart proof and 2-column proof of the common segments theorem. So we're going to prove this theorem right here. And we're actually going to do it in a flowchart proof first, and then we're going to take that and write it in a 2-column proof. First, we are given that segment AB is congruent to segment CD. We're asked to prove that segment AC is congruent to segment BD. So in our flowchart proof, segment AB is congruent to segment CD. Why? That's what we're given. Well, look at that arrow down right here. Arrow down. If we know those segments are congruent, I don't know why I did that. If we know those segments are congruent, we know their lengths are equal by the definition of congruent segments. Moving on, and right up here, BC equals BC. So the length of segment BC is equal to the length of segment BC. Because we don't have BC mentioned anywhere, and I don't always see this in proofs, but I tend to like it, that's the reflexive property of equality. We're using the length of BC in our proof, especially on both sides of the equal sign, which is what we're about to do. So I'm going to actually change this back to this. Right here, okay, we're actually going to move to this, but we're using these two right here, the fact that AB is equal to CD and also BC is equal to BC. So what I'm going to do is I'm going to add BC to AB on this left side, and then I'm going to add BC to CD on the right side of that equal sign. And that's just the addition property of equality. I added the same thing to both sides of my equation. So now up here, again, we're just starting with this. There's no like chain of thought that leads to this. We just know that AB plus BC equals the whole thing, AC, and that BC plus CD equals BD. What is that? That's the segment addition postulate. Okay, so now you can see in this box right here, I get that AC is equal to BD. How do I get that? I've got some things color-coded here. I've got that AB plus BC in red is equal to CD plus BC in blue. Look up here, AB plus BC, that's right there. Well, that's AC. CD plus BC, that's right here. That's BD. So if these two are equal, and each of those by themselves equals AC and BD, then I can set these two equal by the substitution property of equality. And now, because I know those lengths are equal, I know the segments are congruent by the definition of congruent segments. So now let's take this flowchart proof and write it as a two-column proof, which is what I like the best. First, segment AB is congruent to segment CD. We're given that. Then the length of AB is equal to the length of CD by the definition of congruent segments. So we just wrote, let me write it in a different color pen. We just wrote this and this. So now we're going to start with BC equals BC. That's the reflexive property of equality. Then right here, that's our next one. AB plus BC equals CD plus BC. That's the addition property of equality. Then we're moving up here to the segment addition postulate. That's 5. Then we're moving right here. Okay, AC equals BD. We use the substitution property of equality. And our last and final step is we're writing what we're proving, which is segment AC is congruent to segment BD, and why, the definition of congruent segments. And that concludes today's notes over flowchart and paragraph proofs. I hope it was helpful.